All right. Welcome, everyone. Thanks for coming to my talk, Infrastructure as Architecture. I'm going to talk a little bit about kind of the past, the present, and the future of infrastructure and why I'm so excited about the evolution of infrastructure and why I really believe that infrastructure is becoming part of our applications architecture in a very fundamental way. And I'll talk about why that is. My name is Joe. I founded a company called Pulumi. I am so excited about infrastructure that I decided to found a company entirely focused on it. So hopefully this is a lightning talk, so it's going to be 15 quick minutes. But by the end of it, I'm going to try to convince you that this picture is kind of broken. So in all seriousness, one of the reasons we founded Pulumi, the opportunity we saw was, my background is from the development world. I have a lot of friends with background in infrastructure, and I think we're still operating, even though we've come a long way in this world of DevOps, and really modern cloud architectures are fundamentally changing the way we build applications. We really haven't changed kind of the way our teams interact in a fundamental way. We still have, developers focused on applications, writing code, and every day it's code, code, code. And on the other hand, we have infrastructure teams who are really focused on the infrastructure. And this is for good reason. Infrastructure is complicated, especially when it comes to networking and setting up clusters. But increasingly with modern cloud architectures, we want to bring more of those closer to the application development side of things. And I'll talk about why that is and how we might be able to do that. And my thesis, and I'm going to try to convince you, is that infrastructure is important for all of this. I think, for developers, you have infinite capabilities that are an arm's length away. Whether that's data services like hosted data lakes or hosted AI services or serverless functions or container services, the cloud is kind of your new superpower in a sense. If you can take those and assemble those building blocks into your application, the sky's the limit. If you're an infrastructure engineer, similarly, all these capabilities help you to build larger and more powerful systems. But if you can build bridges to your developers, your entire team goes faster. Your developers can be self-serve. They can build, their own great solutions. Your whole team will go faster. You're not always going to be sort of the one at the last mile who has to take care of literally everything to do with the infrastructure. And in many ways, the cloud becomes your new superpower as well. And I think it's the combination of these two where magic kind of happens. And to understand kind of why we are where we are, it's interesting to look at kind of history, right? It turns out if you rewind the clock to the beginning of kind of modern computing, there was a lot of research into distributed systems. Most of the problems, the hard computer science problems back in the day were, how do you deal with the fundamental asynchrony of hardware? How do you get multiple computers to talk to each other? This is around the time that ARPANET, before the internet was coming. So you look at Dijkstra, and a lot of the fundamental primitives were born out of this that now are used in asynchronous programming and distributed programming. Even down to the level of semaphores and mutexes and these core concepts, and they've resurfaced over the years. I think right off the heels of that, in the 80s and 90s, you saw a lot of focus on concurrent and distributed languages. The idea that you take that asynchronous distributed programming approach and really bake it into the programming language. It was part of how you built applications. It wasn't, an afterthought. Even, take a look at Smalltalk. Smalltalk is based on that notion of objects sending messages to each other in a message passing way, very much like our modern RPC systems. And Erlang, Erlang is still popular to this day and it really pioneered a lot of these concepts. And so every language here brought its own contribution to this space. And there are many more that I couldn't possibly list on a single slide. But the idea here was this was part of building your application, writing your code, that you would think about these concepts in a fundamental way. And then the internet came along, and this, obviously fundamentally changed literally everything. And then a series of fundamental changes followed, including virtualization in 1998. And this really was the fundamental capability that made the cloud possible, which is now you could actually go from thinking about hardware as physical entities managed by human beings to being logical entities that were managed by software and that you would program, that you had software that was managing computers, virtual computers. And it was a very powerful capability. A few other things then happened. Multicore happened. This old notion that processors just got faster over time stopped. suddenly, almost overnight. And this notion that, if you've heard of the phrase, Andy giveth and Bill taketh away, the idea was Andy Grove, Intel, they kept shipping faster processors, and by the time they could ship them, Bill Gates at Microsoft had figured out how to consume all the available compute power. And this virtuous cycle really was what gave way to the modern PC era. And then mobile. And mobile introduced, this notion that you'd have connectivity amongst many moving pieces. And to deal with all of this, we invented a lot of new programming constructs. Promises actually was something that came out of many of those early, 80s and 90s programming languages. Then we sort of reinvented callback hell, if you will, where now, we've got dealing with promises and callbacks. And so we invented new constructs that are now in our programming languages. And it took over a decade to do this, but now we have async await and C# and JavaScript. And then, of course, Go, something I think we're all familiar with. And it turns out Go's concurrency model borrowed heavily from those early pioneers in communicating sequential processes, CSPs. So Go routines and channels were fundamentally inspired by that work. And who could forget, Amazon Web Services launching. And I think this is the point where it was the point of no return, where now we're on this cloud journey. And then now you look at the kinds of infrastructure available, it's impressive, right? Each one of these providers, and I couldn't possibly list even a fraction of them, offers infrastructure in a different way, whether that's compute or storage, application performance monitoring, CI/CD, databases, queues. This is infrastructure. Each of these is a building block that can be used to build a system architecture. And as a developer, that's really exciting. And as an infrastructure expert, that's really exciting as well. And so this is kind of what I'm talking about in terms of these capabilities to build architectures such as this one. So in many ways, we're sort of back to the future of distributed computing. And the question is, okay, how do we program these things? And how do we build these systems? Well, thankfully, everything I've listed is programmable. This is a key enabler in our ability to create systems and fully leverage these for distributed systems. And you look at, VMware, every virtual machine, everything you might want to do with a virtual machine, you can do through software. Software-defined networking brought a similar approach to how you define and manage networks. So you didn't need physical switches anymore. You could actually just write some code and manage your network, through software. And so the basic idea there is everything has an API. And this is the fundamental capability that has enabled the entire ecosystem. If I want a server, I can literally go into a web browser and put this URL into my web browser and get a server. Now, most of us wouldn't do it that way. We'd write a program that uses a REST API. We build layers of software on top of that. But that fundamental capability that I've got access to these rich APIs for literally every piece of infrastructure that's available, infrastructure has become software. And because of that, we can apply software engineering capabilities and techniques. Similarly, SDKs. Every one of these APIs has a rich SDK built on top of it and in our favorite language, whether that's Go, Java, Python. What this means is we can now bring those capabilities into our code. We can write scripts and one-off things that can automate, aspects of our infrastructure, or we can actually embed it into libraries. And in fact, Kubernetes, in many ways, leverages this capability to get its job done. Allocating load balancers or persistent volumes. This is really an important capability and can be brought into applications as well. And on top of all of that, we've got these infrastructure as code solutions. And infrastructure as code enables us to really rigorously and in a reliable way provision infrastructure, update infrastructure, manage infrastructure, and really bring it closer to our application code. And this, obviously has a long history of, dating back over 10 years, with CF Engine, Chef, Puppet, and, more recently, my company, Pulumi, and also Terraform. And this gave birth to, this at least in part, the DevOps era of bringing more software engineering discipline to how we do operations. And in this talk, the conclusion is that we're really at the place where we can finally take this to the last mile. So great. Our infrastructure is programmable, and that's a fundamental capability that we can now use to build larger systems. And let's see how that might work. This is, in computer science, how have we gotten to where we are? Well, we've built bigger things out of smaller things, right? We had assembly language, then we built large, programming languages. We had operating systems with very low-level APIs, and we built programming models on top of those. We always keep building bigger things on top of smaller things, and infrastructure is no different. And if you look at the primitive building blocks, it's on one hand bewildering, on the other hand amazing, right? We've got over, or just about 200 services in Amazon across compute, storage, databases, networking. Azure, basically the same story, different flavor, different in the details, similar in the concept. GCP, of course, literally everybody I had on the previous slide has these infrastructure services that are building blocks we can use to create amazing applications. And it's not just the major infrastructure providers. Most of the folks on this slide, in one way or another, this is the CNCF landscape slide, offer programmable infrastructure services. And these are all building blocks that we can now pull into our application and build amazing things. So now it's time for a virtual demo. Because it's a lightning talk, I only have 3 minutes left, so I'm not gonna be able to do a real demo. So I'll show you some code instead. This is an example in Pulumi where we're creating an Amazon virtual private cloud. This is basically an isolated network that can have various subnets and route tables and NAT gateways and things like that. We can see here it's comprised of a lot of different pieces. We've got a VPC, internet gateway, route tables, et cetera. And for every availability zone, we're going to create different, subnet routes. So this is great. Being able to use code is really powerful. I can do for loops over the availability zones. I don't have to copy and paste. I've got real code. That's amazing. But man, that's a lot of boilerplate to remember every single time I want a VPC. Since we have languages, we can now start building reusable building blocks and components that are higher level abstractions that synthesize out of all of these lower level pieces. And so what if we could just say, hey, give me a VPC with 2 AZs, give me a Kubernetes cluster that uses that VPC, boom. I've taken thousands of lines of what used to be YAML, is now code, and now I can actually put it in a reusable building block and reuse it over and over again and know that I'm gonna get it right and not have to remember all of the details of how to set up a VPC. That's amazing. Gives us this nice spectrum of productivity to control, and we can decide kind of what makes sense for us. Obviously, I'm showing Pulumi here, but the general idea is that we're now at the point where infrastructure is programmable and it's composable. And that's what leads me to conclude infrastructure is architecture. Infrastructure is the way that we will architect and build our distributed systems in the future, and we're just getting started. And that's really exciting. So to me, if you're a developer, if you're an infrastructure engineer, it doesn't matter. The cloud's your new superpower. We're ready to break down these walls, turn it from spiky brick walls into rainbows and happy teams. And that's it for me. Thanks for showing up. I hope you had a good time. I hope you learned something. If you want to check out Pulumi, it's upper left here, pulumi.com. If you want to follow me, check me out on Twitter. And that's a wrap.